Hi everyone. So before I start, uh, do let me know two things: that you can see me clearly, you can hear me clearly, and you can also see the iPad screen. Is the iPad screen also visible? All right, all right, all right, all right. No problem. We will start at 5:10 p.m. So another 7-8 minutes. Let everyone join. Then we will start at 5:10. Okay. Going off mic and camera for next 7-8 minutes, starting at 5:10. Hi guys, good evening. So let me define agenda for today's class and then I would begin with the class. Okay. So on agenda, we would discuss a little about NSET, the different modules in this exam. Then we'll touch on the topics. I would share some preparation material with you along with the topics. So let me call it topics and resources. I hope I am clearly audible. So the second topic is topics and resources. The first one is a brief about NST sections. Okay. Third one is then I have to help you prepare for the exam that is about to happen. So I have a series of questions. So series of questions. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10 questions. 10 questions. Okay. So out of these 10 questions, I have to cover these 10 questions across 2 sessions. There are 10 questions. So I have to cover it across 2 sessions. Today is one session. I think another session is on 13th of March. So I'll cover 5 today and 5 in the next class. Okay, or 4, 6 or 6, 4, whichever way we can do it. I'll try to do 5 cross 2. 5 questions, 2 sessions. Today is the first session. All right. So let's begin now. Let's talk about the NSET sections. So majorly 3 sections. One is logical reasoning, things like family trees, puzzles, etc. Okay. The second part is mathematics. The third part is learnability. So majorly I will focus on these two, learnability and mathematics, because logical reasoning, your logical reasoning would be better than me. I am an old guy, you are young people, your mind is sharper, so I believe your logical reasoning would be better than me. All right, so I have to help you with mathematics and learnability. In mathematics, now coming to the second part of the agenda, and the total number of marks is 180. I think this is 65, 65, this is 50, and the rest two are 65, 65. Okay. The key thing here is this learnability part. Yeah, English is removed. Yeah. So I think in January, when I took the session in January, English was still there, but since then I think English is not a part. Okay, verbal ability is no longer a part anymore. So only 3 parts: logical reasoning, mathematics, and learnability. Moving forward, so let me discuss each one, a line about each one. Logical reasoning is simple thing, simple puzzles or simple logic, very cat-like, for example, family trees, etc. Mathematics have 6 topics. I'll discuss all the 6 topics and from where you could prepare each one. About the learnability, in this section what happens is you are given an article. That article may or may not related to be a computer science topic. Majorly it would be related to a overlap of mathematics and computer science. Overlap of maths and computer science. So, and then we would try to learn fast. Then we would, after teaching you something via an article, we would just ask a question on the basis of the article. So that discussion, that question may build upon more knowledge or on your understanding of the article. Okay, so this is the most important part. In fact, maths is also the topics of the maths are also those topics which are important for computer science. Okay, so what we have, so I will take 2 sessions. What we try in these boot camps is we try to reverse engineer the mind of the person who has set this exam. So I'm in your team. How am I in your team? So there is one instructor. His name is Kshitij, or I do not even know, maybe the instructor. So that guy is good with computer science. That guy is good with maths. So he has set the exam. The name that I said, or maybe there's some other instructor. But regardless of whoever the instructor is, that guy would be good with computer science and maths, and he would set the exam. Okay. And I have to guess what kind of articles he would share in the learnability section and post. So I have to try and reverse engineer his to share the kind of questions that you might be facing. Okay. Discussing a very brief on topics and resources to prepare, and then I would start with the first question. So topics and resources. Is there a lag? Okay, I am just waiting for 1 minute for you to say that everything is fine. I hope everything is fine now. Just give me 1 second. Let me rejoin. How about now? Do we still have a lag? Okay. Okay. No, it's fine now. All right. If it's fine, I hope you can see the iPad screen also. Uh, Back again. Let me know if the lag is gone or not. I hope it is better now. I've rejoined the internet. Okay. Great, Vardhan. Great. Thank you very much. All right. Okay, 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 okay. All right. If everything is fine, I want to start again. So, topics and resources. This is for maths and learnability. Okay. So, the first topic is number theory. Number theory. Things like odd, even numbers, prime numbers, modular arithmetic. So, one topic that I would want to highlight right away is modular arithmetic would be very important for you. Modular arithmetic. Okay, Where to prepare it from? Where to prepare it from? The best place to prepare it from is a resource called Hacker Earth. Hacker Earth has 2 articles on number theory. So search Hacker Earth modular arithmetic. There would be 2 articles. Please read those 2 articles. This is the first resource. The next topic is exponentials and logarithm. Exponentials and logarithm. Here I would highly recommend you to be thorough with binary number system. Binary number system. Of course, binary number system has to be important because in computer science, every data is stored in terms of 0 and 1s, in bits only. Okay, so binary number system is very important. The next one is probability and stats. For probability and stats, no new topic. Your 10th, 12th information is enough. No new source. I would not recommend anything. For permutations and combinations. Permutations and combinations. So these questions would get converted into a topic called recursion and DP in programming. So I would share at the end of the lecture, I will share you 4 videos. In those 4 videos, I have given reference of another set of videos. So those videos you will have to watch. So I have created some resources on a YouTube channel called Pep Coding on recursion and DP, and I would advise you to watch those questions. I'll share you which questions. The next resources topic is ratio and proportion. No resource from my side. Your 10th, 12th information is enough. And similarly for sets, that is Venn diagrams, you decide wherever you want to prepare from. So my suggestions would be related to permutations and combinations. In exponentials, I say do binary number system. In number theory, I highly recommend you to do modular arithmetic from Hacker Earth. Okay. So this is about the top topics. At the end of the lecture, I would share the resources specifically. If not today, then in the next lecture. Ideally today itself. Okay. So let's start with the questions. So I have a set of 10 questions ready. Let me start with number theory. So 5 questions that I would want to do today is, there is a question this, another question is xy plus xz, another question is, so this is maths plus learnability. This is a very interesting puzzle, Benjamin bulbs. So these 3 are related to number theory. Then I would start with binary number system, basically number system. So there is a quiz called rats and poison, and then I have to do a little number system with you. So this would be about binary number system. Okay, so these 5 questions I would try to do today with you. All right, so the first question, very simple question, but sometimes what the data that the question shows to you, it may have layers behind it. For example, so the first question is, there are 2 numbers P and Q. Also it is told that P plus Q equal to 1999. Yes, Lokesh. So this is the repetition of the older lectures. So my assumption is that new students are coming in and they are going to appear for NSET for the first time. So that is why. If you have attended one of the previous lectures, you already know what I am going to speak about. Okay. So P and Q are prime numbers. And it is told that P plus Q equal to 1999. Okay. You have to tell me what is the product of P into Q. What is P into Q? I hope the question is clear. The question is very simple. P and Q are prime numbers. And also it is told P plus Q equal to 1999. You have to tell me what is P into Q. What would be the product? And you have to also share the reasoning. How did you deduce it? So there are 2 parts to it. What is P into Q and what is the reasoning behind your answer? Yes, Virat. Problem, Subha. So what we generally do is we share the video of this on YouTube. So on our SST YouTube channel, we post these videos. So don't worry about that. You guys are supposed to now try to solve this question. It is your question now, and please do not write the solution to everyone. Please do not write the solution to everyone. Write the solution in private to me only, so that if you reach the answer, you do not share it with everyone. So the question is this: P and Q are prime numbers. P plus Q equal to 1999. You have to tell me the product of P into Q, and you have to tell me the reasoning behind it. Yes, Priyanshu, I will discuss that. But for now, I have to discuss this question. After I am done discussing this question, then I can come back to your question also. I only have one answer so far. I am expecting more answers. I only have one answer, and that is correct. Lokesh, your answer is correct. Parth, your answer is correct. But you also have to share the reasoning. How did you deduce that answer? The answers are correct. For Parth and Lokesh, I only have 2 correct answers so far. I am expecting at least 3-4 correct answers before I proceed with the solution. Bhavesh, correct. But also share the reasoning, no? Lokesh, your reasoning is correct. Correct, Swarnim. Great. So I have 4 correct answers. Yes, Anushka, 4 correct answers. But the reasoning was not shared by only 2 people. Alright, now let's discuss the question together. Okay, a few people have solved it. Let's discuss the question together. So one of the information is readily available in this question, but one of the information is hidden. So let's talk about it. It is told that P and Q are prime. And what is their sum? What is their sum? Their sum is 1999. 1999. Okay? Now think about one thing. This is an odd number. This is an odd number. And when is the sum of two numbers odd? If the sum is odd, what does that tell me about P and Q? So let's meditate about that. The sum of 2 even numbers is equal to what? You have to tell me the sum of 2 even numbers is equal to what? An odd or an even? If I add 2 even numbers, do I get an odd answer or an even answer? Waiting for a response. If I add 2 even numbers, I get an even. Correct. Okay. If I add 2 odd numbers, what do I get? Odd or even? If I add 2 odd numbers, what do I get? Odd or even? Even again. Okay. So when do I get an odd? When do I get an odd? When there is one even and the other one is odd. Or the first one is odd and the second one is even. So if one of them is even, the other one of them is odd, my sum is odd. So this tells me one more thing. This tells me one more thing, that one out of P and Q is even. The other one is odd. The other one is odd. Do you agree with this deduction? Do you agree with this? That yes, if P plus Q equal to 1999, which is an odd number, which implies that one out of P and Q is even, the other one is odd. Let's say P is even, assume P is even, Q is odd, or whichever way you want. Okay. But you also know one more thing, that P and Q are prime. So this is one fact. The other fact was given to you. P and Q are prime. P and Q are prime. Now my question to you, very important question to you. Is 4 a prime number? Is 4 a prime number? Is 6, 8, 10, 12, 14 a prime number? Is any of them? So my question is, can an even number be prime? Can any even number be prime? Can any even number be prime? I think even numbers are not prime because they get divided by 2. So is there any even number in the world that is prime? Yes. The smallest even number is also a prime number. So 2 is the only even prime number. 2 is the only even prime number. Even prime number. So that solves our problem. P is even and P is prime. So P is 2. and P plus Q was 1999, implies Q is 1997. And you were supposed to tell me the answer of P into Q, so that is 2 into 1997, so 3994. Is the reasoning clear? Is the reasoning clear? Do you see the cleverness behind the question? So the question setter had played a clever trick. The clever trick was, he showed you one data that P and Q are prime. He showed you that data, but he never showed you the other thing, that P plus Q is equal to an odd number, implies one of them is odd and one of them is even, and the only even prime number is 2. So one of them is 2, the other one is 1997, so we get the product 3994. Okay, so this kind of questions you can expect. This is a cat kind of a question. So I say this comes under the topic number theory. Number theory. All right, so let me take you through another question on odd even. Okay, yes Lokesh, you can, of course you can, of course, because if you have attended the previous lecture, this is the first 5 questions are going to be same. All right, xy plus xz, very interesting question, and again the question is on odd and even. So let me pose the question to you. So question 2, these are not the learnability questions, these are mathematics questions. So with the third, fourth question, I would start with learnability. Question 2. Now with question 2, it is told to you xy plus xz is odd. This is told to you. Xy plus xz is odd. Rahul, we can discuss that also, no problem. So now that you have pointed out, in the next class I will bring a question on this topic. Don't worry about that. Okay, for now I want you to focus on this. Xy plus xz is odd. Which of the following statement is false? Which of the following is false? False. What are the 4 options? A, B, C, D. First option, xy plus yz plus xz is odd. Xy plus yz is odd. You have to tell me which one is false. The next one is yz plus xz is even. And the last one is x raised to power y raised to power z raised to power x is odd. So you can give me the answer. But you have to give me the answer only in private chat, and you also have to share the reason of your answer. The first deduction is correct. Deepak Mishra and Janish Togadia, the first deduction is correct. Xy plus xz is odd implies x into y plus z is odd, implies both of them are individually odd. Okay, good starting point. But I leave you with the question for a while. Take 5 minutes, try to give me the answer, but do not give me the answer without the reasoning. You have to give me the reasoning. Without the reasoning, no answer is an answer without the reasoning. So if you cannot give me the reasoning, it does not count. Option C is not the answer. Option C is not the answer. Yes, Virat, correct. Correct. A very loose reasoning, but of course on the chat only that much can be written, no? So good enough. Thank you. Bhavesh, correct. Subha, no, C is not the answer. You have to tell me which one is false. Which one is false, not which one is true. So 3 out of them are true, but only one of them is false. You have to tell me which one is false. So when you say C, you have to tell me the reasoning also. No, B is not false. Let's solve it together. Okay. All right. So we will use elimination method. What was given? Xy plus yz is odd. Okay. So x into y plus z is odd. Implies x is odd and y plus z is odd. Is this correct? If the product of 2 numbers is odd, then both numbers are odd. Is this correct? If the product of two numbers is odd, both have to be odd. Okay. Now we know about x certainly. About y and z we do not know for certainly. We know that their addition is odd, but we do not know about them individually. But can I say this only means two things? If y is odd, z is even. And if y is even, z is odd. Is this correct? Because y plus z is odd. The sum is odd. So one of them has to be odd, the other one has to be even. So y is odd, z is even, or y is even, z is odd. So I can say I have two situations. X is odd, y odd. So my two situations is this. X odd, y odd, z even, or x odd, y odd, y even and z odd. Do you guys agree that if xy plus yz is odd implies one of these two things, that x and y are odd, z is even, or x and z are odd, y is even. Okay? Alright. So now let us try to evaluate each one of them. Let me pick the first one. Xy plus yz plus xz is odd. They say for the A condition they said xy plus yz plus xz is odd. Okay. So this is, if I pick the case 1, odd into odd plus odd into even plus odd into even. Okay. Odd into odd is odd. This is even. This is even. Now, what do you think? Even plus even is even. Odd plus even is odd. And that is what they said. That is what they said. So A is correct. The option said that xy plus yz plus xz is odd, and that is correct because we got a odd only. Is this correct? That yes, because these two situations are possible. I used the first one of them and I tried odd into odd plus odd into even plus odd into even. So this is even, odd plus even plus even plus even is even, odd plus even is odd, and that is what they said. I can also check for the second one. For the second one also it would come out true. X is odd, y is even, z is odd. So odd into even plus even into odd plus xz, both are odd. Odd into odd. So even plus odd. Same situation. Even plus odd equal to odd. And that is what they said, that it is odd. So A is clear. Alright. Rahul, I might be coming to SST somewhere around July. Okay, but for now let's focus on this question. So I can see your questions. I would revert to them once I am done with this question. Okay. B. They say xy plus yz is odd. Alright, let's try. Xy plus yz is odd. Okay. Case 1. I'll use the case 1. Odd, even. Odd, even. So odd into odd plus odd into even. This is odd plus even equal to odd. So that is what they said. So it is correct. Or I can use the second case. Odd, even, odd. Okay. Odd into even plus even into odd equal to okay. So second one is interesting actually here. X is odd, y is odd, y is even, and z is odd. So I used odd into even plus even into odd. So the first one is even, the second one is even, and I got an even. And they said xy plus yz is odd. So is B false? Is B false? My question to you, if you are actually following me, please see this. So we had deduced x into y plus z is odd. X is odd, y plus z is odd, implied either y is odd, z is even, or y is even, z is odd. So we had two cases. The first case was x is odd, y is odd, z is even. The second case was x is odd, z is odd, y is even. Alright. So for case B, for option B, case 1 was correct, but case B is incorrect. But that does not make it false. So for the situation to be false, for the option to be false, it has to be false for both the cases. If it is false for both the cases, then it is always false. So xy plus yz is odd is sometimes true, sometimes false. We cannot definitely say that this is always false. So even that is not our answer. Next one, yz plus xz is even. Yz plus xz is even. Let's check out. Case 1. Case 1 was x is, I think, odd or even. That was the case. So odd or even, odd into even plus odd into even. And they say this is even. They say this is even. Is even. No problem. Even plus even is even. So for case 1 it has proved true. I should not check for case 2 actually. If for one of the cases it is true, then it is true. But let's check out for the other one also. The other one was odd, even, odd. So even into odd plus odd into odd. So even plus odd is actually odd, which makes it false, but it had to be false for both of the cases. It was not false for both of the cases, so this is not my answer. Finally, D. Let's check out D. They say this is odd. Let's check out if it is false for both of them. Y raised per z is odd. Case 1. 1 was odd, odd, even. Okay. So odd raised per odd into odd raised per even into even raised per odd. So what do you think about powers? What do you think about product? What do you think about product? If in a product, let us say I am multiplying 10 numbers, even if a single number is even, what does that tell you about the product? Let me rephrase my question. Let us say I am multiplying 10, 15 numbers. Even if there is a single number that is even, what would be the product? The product will be even. And in this product, can you see for these powers only means that it is multiplied many times, odd into odd into odd many times. Then odd raised per even means odd into odd into odd many times. And even raised per odd means even into even many times. So in this product, there is at least a single even number. So this product has to be even. And they said it is odd. So false. Let me check for case 2 also, which was odd, even, odd. X is per y, y is per z, z is per x. So odd raised per even raised per odd raised per odd. Here also odd, odd, odd many times, then even many times, then odd, odd, odd many times. This is also even. So for case 1, it is even. For case 2, it is even. So both cases led to a false situation. So this statement is false. Is it correct or not correct? Do you see how we work through it? So it could be false if it was going to be false for both the cases. So only option D is false for both the cases. It does not matter whether y or z is odd and the other one is even. So we knew that x is always odd, and out of y and z, if y is odd, then z is even, or y is even, then z is odd. And for both these cases, this situation always come out as even, because in the product at least there is a single even number. So let me say it in a few words. See, x was always odd. Out of y and z there was at least one even. That was a deduction, no? The deduction of x into y plus z is odd was x is always odd, and out of y and z there is at least one odd and one even. So out of x, y and z there is at least one even. If there is at least one even, in this product there is always an even number. In this product there is always an even number. Let me again summarize it for you and it will become easy. So what was given to us? xy plus xz is odd. Okay. Implied x into y plus z is odd. Implied x is odd and y plus z is odd. Y plus z is odd implies one out of y and z is odd, the other one is even. The other is even. So I can summarize this as x, y, z. Two are odd, one is even. And what does that tell me about? X is per y, y is per z, z is per x. Don't worry about the powers. Look at the bases. At least one of them is even. If at least one of them is even, then the product is always even. Means the product is always even. The product can't be odd. Is this clear or not clear? Yes, Harsh, you can expect this level. So this is cat level basically. So you can expect cat level for maths. Is the solution clear or not clear? That at least one of them was even. That is why the product will always be even. Cool. 2 questions done. So these were maths questions. Now I will pose a puzzle to you on number theory, but there's a lot of story around the question. So a lot of story around the question. Otherwise, it is a very simple question. It's a normal number theory question. But because there is a lot of story, so you might find it difficult. So this is question 3. Before I start with the question, I just want to tell you it's a normal number theory question. Normal number theory question. Okay? But around the question, there is a lot of story. And because of that, you might get confused. Okay? So this is how the question goes like. Please listen to the question carefully. There are 100 bulbs in a colony, in a hostel. You are going to a hostel, so let's start speaking about a hostel. So there are 100 bulbs in a hostel. Now boys are mischievous. Okay? So they went to the main switch and toggled the main switch. Main switch was messed up with by the hostel boys 100 times. 100 times. Okay? So, how many bulbs? 100 bulbs. And the hostel boys messed with the main switch of the hostel how many times? 100 times. 100 times. Okay? And every time you mess up with the main switch, the voltage fluctuates. Initially, all bulbs were off. This is daytime, not nighttime. They are doing their mischief during the daytime. They are trying to fuse a few bulbs. Okay? So, initially all bulbs were off. Now the interesting part start. On first fluctuation, when they mess up with the main switch, the voltage fluctuates. Okay? On the first fluctuation, all bulbs toggled their state. So all were off, all became on. On the first fluctuation, all bulbs toggled their state. Okay. On second fluctuation, all even bulbs toggled their state. On third fluctuation, all bulbs that are multiple of 3 toggled their state. Toggled means what? If they are on, they become off. If they are off, they become on. Toggled their state. Is the question clear so far? So let me revise the question so far. How many bulbs? 100 bulbs. How many times did you guys mess with the main switch? 100 times. When you mess with the main switch, the voltage fluctuates. Mess does not mean you turned it on or off. Mess means you messed. You tried to do something there and the voltage fluctuated. Initially all bulbs were off. On the first fluctuation, all bulbs toggled their state. So all were off, all became on. On second fluctuation, only the even bulbs toggled their state. So even bulbs became off again. So is it fair to say that after 2 fluctuations, all odd bulbs are on and all even bulbs are off? It is fair to say. If you are following me, you would be able to say yes. So initially all were off. After first fluctuation, all 100 are on. After second fluctuation, even bulbs toggled their state, so they became off. Odds did not, so they stayed on. So odd ones are on, even ones are off. But now the question becomes complex. How? On third fluctuation, all bulbs that are multiple of 3 toggled their state. On fourth fluctuation, multiples of 4 toggled. so on and so forth. This happened 100 times. On 100th fluctuation, only the 100th bulb, the only multiple of 100, toggled its state. Only 100th bulb toggled its state. So I just want to ask a question. In the 50th fluctuation, which two bulbs will toggle? Which two bulbs will toggle? Multiples of 50. So that is 50th bulb and 100th bulb. Is this clear? In the first fluctuation, all multiples of 1, that is all the bulbs. In second fluctuation, all multiples of 2, that is all even bulbs. On third fluctuation, all multiples of 3, 33 bulbs out of 100. The last one is 99. On fourth fluctuation, all multiples of 4. On 50th fluctuation, all multiples of 50. On 100th fluctuation, all multiples of 100. Okay. So now you have to tell me, after 100 fluctuations, question, after 100 fluctuation, which bulbs are in on state? In on state. Which bulbs are on? So that is what the question is. So my question to you, is the question clear? My question is the question clear to you? So my suggestion to you, when such a big question comes, reduce the size of the problem. Try to think it for 25 bulbs, 25 students, 25 fluctuations. If you can solve it for 25 bulbs, or if you can solve it for 10 bulbs and 10 fluctuations, then the same rule would apply for 100. Janish, correct answer, correct answer. Virat, correct, but you also have to tell me which bulbs. No, Deepak, first bulb is not on. Actually, first is on, but there are more bulbs that are on also. So this question would take you some time. So please do not be in a hurry to answer. Take 5 minutes. Take 5 minutes. I will go and drink water. You take 5 minutes. Try to solve this question. Do not write the answer in public. Please write the answer to me with reasoning. And after 5 minutes, I will discuss. Prime numbers are not on. It looks like the prime numbers would be on, but not true. Not true. Virat, correct answer. Correct answer. Amazing. Very good. Very good. Very proud. My suggestion to you. Try to solve for 9 bulbs and 9 fluctuations. 9 bulbs and 9 fluctuations. That would teach you something. Or you can do it for 10 bulbs and 10 fluctuations also. So do it for 10 bulbs. Try to solve the problem for 10 bulbs. Something would become clear to you. Aman, I have solved these questions previously. So I would not say that I am smart. I have just solved them previously. Okay. And some mathematical logic of course helps. Bhavesh, correct answer, correct answer. Janish, correct answer. Reasoning is also correct. So I give the question to you. You have 5 minutes. It is 5:53 right now. I will discuss the solution at 5:58. Till that time is your opportunity to apply your mind. It's a number theory question. The puzzle is just to confuse you. It's a number theory question. Okay. So let me go and have water and let's discuss it at 5:58. I highly recommend you run the example of 10 bulbs. You would get to know the answer. Then we would discuss why is answer the answer. No Rishi, incorrect. Deepak, incorrect. No Sharman, incorrect. So, all right, I don't think you're going the right direction. Let me discuss the solution. But before I discuss the solution, I want your attention. So, do I have your attention? Should I start solving or do you want 2 more minutes? I have your attention. All right, thank you. Thank you. Let us do it for 10 bulbs. Okay, I suggested let us do it for 10 bulbs. That would have helped you. Okay, bulb number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So how many bulbs? We are not solving for 100. For now we are solving for 10. So the voltage was fluctuate how many times? For 100 bulbs the voltage fluctuated 100 times. For 10 bulbs the voltage would fluctuate 10 times. Now tell me which all bulbs will be touched when the voltage fluctuates for the first time? For the first time? No. For the first time, all bulbs. All bulbs. All bulbs. All bulbs. First fluctuation touches all bulbs. So that is what we said in the original question, no? See? On first fluctuation, all bulbs toggled their state. All toggled their state. So this does not tell me that they are on. This only tells that they toggled. Okay? Now for the second fluctuation. Now tell me, for the second fluctuation, which bulbs will toggle? Which bulbs will toggle? You have to answer no. It's an easy question, yaar. All even bulbs will toggle. So this bulb, this bulb, this bulb, this bulb, this bulb. So 2, 4, 6, 8 and 10 will toggle. For third fluctuation, which all bulbs will toggle? Multiples of 3. Which all bulbs? No, not all odd. For third fluctuation, multiples of 3 will toggle. Multiples of 3. That is third bulb, sixth bulb, ninth bulb will be toggled. 3, 6 and 9. Now I think you would be able to answer for fourth fluctuation. First question. Fourth fluctuation which will toggle how many bulbs? Will toggle how many bulbs? How many? 2. Which 2? Now which 2? Which 2 bulbs? 4th and 8th. Correct. Multiples of 4. 4th and 8th. I think now we are on the correct path. The fifth fluctuation will touch which bulbs? Which bulbs? 5th and 10th. Correct. 5th and 10th. 6th will toggle only 6th bulb. 7th will toggle only 7th bulb. 8th will toggle only 8th bulb. 9th will toggle only 9th bulb. The 10th fluctuation will toggle only 10th bulb. Are you aligned? Okay. Now let's discuss something else. This bulb was off and let us say it got toggled 5 times. 5 times. So first toggling made it on, the second toggling made it off. On, off, on. 5 togglings, it is on. Okay. And if the togglings were 6, what happens? On, off, on, off, on, off. So what do you see here? 5 toggles, on, 6 toggles, off. So what do you see? So see, 2 toggles have zero effect. So if the number of toggles is even, it has zero effect because one on and one off is paired. Is this correct? Are you aligned with me on this fact that odd toggles equal to on, even number of toggles equal to off only, because even number of toggles means on and off paired, on and off paired, on and off paired. And for odd number of toggles it is on because on off paired, but one on will stay separate. Are we guys on the same page? Now, how many toggles do you see for 1? How many toggles do you see for 1? only one, which is odd. So this is on. 2 toggles, off. 2 toggles, off. 3 toggles, on. 2 toggles, off. 4 toggles, off. 2 toggles, off. 4 toggles, off. 3 toggles, on. 4 toggles, off. So on, on, on. 1, 4 and 9 are on. 1, 4 and 9 are on because they were toggled odd number of times. Odd number of times. Are you guys with me so far? That yes, out of 1 to 10, 1, 4 and 9 will be on because they were toggled odd number of times. Odd number of times. Which are square numbers. Basically, which are perfect squares. Perfect squares. Okay. Okay. So, do you want me to repeat what have happened so far for the 10 bulbs, or it is okay? You don't want to repeat. No problem. Cool. So you have understood it. Okay. Great, 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 great. No, 10 bulbs will not be on. No. 3 bulbs out of 10 are on. Okay. Out of 100. Out of 100. Okay. Now, if we are thinking for 100 bulbs, which all are perfect squares? 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16, 5 square is 25, 6 square is 36, 7 square is 49, 8 square is 64, 9 square is 81, and 10 square is 100. So these all bulbs will stay on. Why will these 10 bulbs 1, 4, 9, 16, 25, 36, 49, 64, 81 and 100 stay on? Because they will be toggled odd number of times. Now why is that happening? Why is that happening? See, you have to tell me, let us say we have 100 bulbs. The 24th bulb will be toggled by which fluctuations? Of course, we are interested how many times it is toggled, but before that we must know by which fluctuations. So tell me, will the first fluctuation touch the 24th bulb? First fluctuation touches all bulbs. So yes. Will the second fluctuation touch the 24th bulb? Yes. Because second fluctuation toggles all even bulbs. Will the third fluctuation touch the 24th bulb? Yes. Because it toggles all multiples of 3 and 3 8s are 24. Fourth fluctuation toggles multiples of 4 and 24 is a multiple of 4. Fifth fluctuation will not toggle it because 24 is not a multiple of 5. Sixth fluctuation will toggle it. Seventh will not, eighth will. Ninth will not, 10th will not, 11th will not, 12th will. 12th fluctuation will. After 12th, the 24th fluctuation will touch this bulb. So what are these? How do they relate to 24? They are factors of 24. Factors of 24. So a bulb will be touched by the fluctuations which are a factor of it. Okay. Now let's see the factorization of 24 and 36. You would see a interesting thing. 1 into 24 is 24, correct? 2 into 12 is 24, of course. 3 into 8 is 24, alright. 4 into 6 is 24. The square root of 24 is somewhere here, 4.9. Because 5 square is 25, so 24 square root would be somewhere around 4.9. After the square root point, there are no new factors. This only becomes a mirror image. 4 into 6 becomes 6 into 4. 3 into 8 becomes 8 into 3. 2 into 12 becomes 12 into 2. 1 into 24 becomes 24 into 1. Do you see this about the factors? That after the square root, there is just a mirror image. So 1 into 24 becomes 24 into 1. 2 into 12 becomes 12 into 2, 3 into 8 becomes 8 into 3, 4 into 6 becomes 6 into 4. Regarding 36, let's see it for 36. 1 into 36, 2 into 18, all right, 3 into 12, so far so good, 4 into 9, 6 into 6, okay, and this is the square root. After this is only a mirror image, no new factors. 9 into 4, 12 into 3, 18 into 2, 36 into 1. The important thing here is, let us say this is n number of factors before the square root. So n number of factors after the square root. So 2n factors, 2n number of factors or even number of factors. And for 36, if this is n, and this is 1, so 2n plus 1 factors, which is odd number of factors. So perfect squares. Yes, Rohit, yes, I'll ask Sahiti to share the recordings with you. Perfect squares have odd factors, odd number of factors. All other numbers have even factors. Numbers have even number of factors. Even number of factors. Okay? Perfect squares have odd number of factors. All other numbers have even number of factors. So whichever has odd number of factors means odd number of factors. Let us say the bulb got touched 5 times. So it was off, on, off, on, off, on. So odd number of factors means it will stay on. And perfect squares have odd number of factors. So all the bulbs which are perfect squares will turn on, will stay on. Deepak, I do not know. I will not be able to answer that question. So is this question clear to you or not? Is this question, the bulbs question, clear to you or not? Anubhav, I'll share the resources at the end of the lecture. Don't worry, I'll share the resources. Okay? But is this question clear or not? Did you enjoy the question? I think it was such a fantastic question. Actually, if you would think the puzzle and the story is just to confuse you, the question is about knowing this thing that perfect squares have odd number of factors. That is what the question is actually. Alright? Alright. Okay. So this was question number 3. I have a very interesting discussion around number system. So do you want to discuss number system or we can also discuss, actually I have to do 10 questions. So, and 5 of them today. So I can also teach you some graphs and I can teach you a very mind-blowing algorithm called Dijkstra algorithm. I would teach you Dijkstra algorithm and then I would ask you a question and you have to give me answer on the Dijkstra algorithm. Okay? So that would be, so just to make this, just to spice up the class, let's do the other one, second one. So, question number 4. I will teach you an algorithm. So in our computer science, there's a subject called data structures. In data structures, there is a topic called graphs. Okay? And in graphs, there is a problem called finding shortest path, which is solved by an algorithm called Dijkstra. So I will show you the algorithm. I'll teach you the algorithm. That is what learnability is. Learnability is first someone teaches you something and then asks a question on what he has taught. Okay. So listen very carefully, ask your doubts. Make sure that you understand it well. So what we try to gauge by learnability is, are you guys good students? Good student is not someone who already knows something. Good student is who sits in the class and is able to understand whatever the teacher is teaching him. Okay, so that is also a good student, no? So it does not matter whether how many marks you score. But what's important is, are you able to take maximum knowledge from the teacher? All right. Oh, of course, Janice. Of course, it could be solved that way. But it was a mathematical problem, no? So I'm assuming that you do not know coding. All right. Coming for question 4, and this question relates to a concept called data structures in programming. Inside data structures, there is a topic called graph. Inside that, there is a problem called shortest path. And for that, there is an algorithm called the Dijkstra. Okay. So I would try to dumb down the question so that you understand the question. So let's say A, B, C, D, E, F, G. Let us say these are cities. These are cities. A, B, C, D, E, F, G are cities, and they are connected by these rods. The spelling of the Dijkstra, Dijkstra. J is pronounced as her. The Dijkstra. All right. So there are cities A, B, C, D, E, F, G, and they are connected by roads. All right. So this road is 10 kilometer long, 10 kilometer long, 10 kilometer long, 40 kilometer long. 2 kilometer long, 3 kilometer long, 3 kilometer long, 8 kilometer long. So this is a graph. A, B, C, D, E, F, G are cities, and they are connected by these roads. Okay. Distances. So the question is, you are given a starting point. A. And you have to tell me the shortest path to every city from A. Shortest path to every city from A. All right. So that is what we are supposed to do here. So let me teach you the algorithm. So starting with the algorithm. Before I start with the algorithm, is the input and output clear to you? Input is this graph with these cities, with these roads, and a starting point is given to you. And what is the output expected? You have to tell me the shortest path from A to every one of them. So your output would be a table. Your output would be something like this. So shortest path to A, shortest path to B, shortest path to C, shortest path to D, shortest path to E, shortest path to F and G. And in shortest path, the output is this table. And you have to tell me what was the route that was taken. For example, A, B, C, D, E, F, G is the route. A, B, C, D, E, F, G is the route. And we also have to tell the weight. If 10 plus 10 plus 10, 30, 32, 35, 38. Okay. So you have to fill this table up basically. All right. So let me teach you the algorithm. So I have to dumb down a lot many parts here. Please listen carefully so that you can give me the answer of the next graph that I would throw to you. This is the learnability part. You are trying to learn a topic and you have to give me answer. Starting point A. Okay, for the next example that I would throw to you. So starting point is A. All right. So you start. So it would be very near to full blown. Don't worry. Okay. So you start with this algorithm. Please remember this algorithm. Remove mark star. Remove mark star. Add neighbor star. Remove mark star. Add neighbor star. So you have to remove this. You have to remember this. I'll start doing it. You soon understand what it is. So the first thing that you add to a tree, for now let's call it a tree. It's actually not a tree. It's something called a heap. But let's call it a tree for now. The first thing that we add to a tree is the starting point. And we say the path from starting point to starting point is A and the cost is 0. So actually initially what I'm saying is, where are we? What is our path so far? and what is our cost so far. Vertex, path so far. What is the path that we have taken so far? Cost so far. Cost so far means how many kilometers we have traveled so far. Okay, so this is the first thing that we have added. So we add the starting point and we say that for starting point the path is starting point itself, and of course because we have not traveled so far, so the distance covered so far is 0. Distance so far, so I would write that also. Vertex, path so far, distance so far. Now I would apply this algorithm. Remove, all right. Mark A. Add the neighbors. Remove, mark, add neighbors. So neighbors are B and D. Neighbors of A, B and D. I would add it here. B and D. B here. And see what the path for B would be. Old path plus this vertex. AB will be the path. Old cost plus this cost. AB cost. 10. Okay. The other neighbor of A was D. So D would be added. Old path plus D's name, AD. Old cost plus this cost 40. Is it clear so far? Is it clear so far? Remove, mark star, and adding the neighbors, basically. Adding the neighbors. Okay. So actually there is a slight mistake here. Slight mistake here. So remove, mark star, work, neighbor star. So this is what the algorithm is. All right. So let me again do it. So you have to remember these two things. You have to remember these two things. I would again do it. Remove mark star, work neighbor star. What star stands for, I would explain. For now, remove mark, work and neighbor. All right. I would explain. For now, mark is this. For now, mark that I have covered you. All right. That is what mark means for now. And the other thing that you have to remember is that in the tree we have vertex, path so far, and distance so far. All right. So let's again start. A, path so far is A, distance so far is 0. Applying the algorithm. Remove. See what is mark. Mark. Forget about the star for now. This is going to be a tree actually. So mark. Work is making the table. Work is making the table. So the path to A is A and distance is 0. All right. That is work. Now neighbor stars. Neighbors of A, that is B and D, add them. So adding B. The vertex is B. The path so far is AB. Old path plus the name. 0 plus this distance, 10. The other neighbor is D. Path so far is AD and 0 plus 40 is the distance so far. I hope it is clear so far. Now in this tree you remove the vertex with the lowest distance. The next lowest distance. Now this is removed. Only these two are there and B has the smaller weight. So I will remove B. Not D. So see, remove mark star. Let's do mark star. Mark work. Let's add it to the table. B from AB path, add the cost 10. Now neighbor star. Now you would understand the meanings of stars. Neighbor star. From this picture, who all are the neighbors of B? Who all are the neighbors of B? A and C are the neighbors of B. No, D is not the neighbor of D. Who is saying D? Rishi ji. Arey, D is far. No. Neighbors of B are A and C. How D is far? So A and C are the neighbors. Now you understand the meaning of star. Star means, so when I say you have to add the neighbors, you don't have to add a marked neighbor. Okay. So for B, now remove is done, mark is done, work is done. I am going to add the neighbors of B. The neighbors are A and C, but I won't add A because A is marked. I will add C. So I will add C. C. And see the path now. AB plus C. ABC. Old 10 plus this 10. 20. CABC 20. Now, in your tree, there are 2 dead nodes, but 2 alive nodes. And which node do we remove first? The one with the lower weight. The one with the lower weight, lower distance. So, will D be removed or will C be removed? Will D be removed or will C be removed? Lower weight. D is 40. C is 20. Which one will be removed? C will be removed because D is 40. No, 40 is lower weight will move. C is 20. So remove C. Remove C. Algorithm. Remove. Mark. Alright. Work. Work is added to the table. C, ABC 20. Alright. So work is done. Now neighbors. The neighbors of C are. The neighbors of C are what? The neighbors of C are what? The neighbors are what? How many neighbors of C do you see? How many neighbors of C can you see? 2 neighbors. B and D. 2 neighbors. B and D. But which of the neighbor is not relevant? B is not relevant because B is already marked. So D is the relevant one. D is the relevant one. I will add D. I will add D. And I hope you would be able to see the path so far, etc. Old path is ABC and add D to it. Old distance is 20 and this is 10. So make it 30. Make it 30. If you see this carefully, the algorithm is very clever. From A to D, there were 2 paths. A to D, there was a direct path. There was an indirect path. And if you see in the picture right now, this is the direct path. This is the path ABCD. ABCD. The algorithm has detected the path ABCD from A to D. Now the graph represents. This algorithm represents that both paths got detected. And my question to you, from the tree, if you see a 30 as well as a 40, which value do you remove? Which value do you remove? Remove 30. Which means ignore 40. Which means ignore 40. Which means we have been able to avoid a longer path to D from A and select a shorter path to D from A. Do you see the cleverness of the algorithm? So the name of the scientist, Dijkstra, I think he and his girlfriend, they went to Paris and he devised this algorithm while in a cafe, while having coffee. So on the napkin, he drew some thing and they discussed this algorithm. So I am not sure whether the story is correct or not, but this scientist and his girlfriend, and they discussed this algorithm in a cafe in Paris. I'm not sure whether the legend is true or not. But regardless, let's remove D. D. Remove. Mark. Remove mark. Alright. Work. Okay. So work is D, A, B, C, D discovered at the cost of 30. Okay. Work is on neighbors. The neighbors of D are A, C and E. A, C and E. A and C will be ignored. E will be added. E will be added. So, E, A, B, C, D, E. The old cost is 30. The edge is 2. I will take the edge, 32. Now see, there is still 40 here and there is still 32. Which one will be removed now? Which one will be removed now? Anubhav, I was discussing the story of how this scientist called Dijkstra devised this algorithm. So he and his girlfriend, they were sitting in a cafe and they devised this algorithm. Alright. So remove E. Okay. Mark E. Work for E. Here's the work. E, A, B, C, D, E. At the cost of 32. Neighbors of E. The neighbors of E are D, F and G. D will be ignored. F and G will be added. F and G will be added. F, A, B, C, D, E, F, 32 plus 3, 35. And G, A, B, C, D, E, G, 32 plus this edge, 8, 40. 40. So I see a 35 here, a 40 here, and a 40 here. So I will remove F. Remove. Mark F. Work for F. F, A, B, C, D, E, F, 35. Work for F. Okay. And now neighbors of F. The neighbors of F are E and G. E is done. So G will be added with a weight of 3. G, A, B, C, D, E, F, G at 38. If you are again cleverly and clearly and deeply looking at the algorithm, there were two paths to G. One of the paths to, so we had taken this shorter path to D. After that, there was one path, and the other path was go like this and visit G via that. Both these paths have been detected. So A, B, C, D, E, F, G and A, B, C, D, E, G both are detected and both are here. A, B, C, D, E, G, A, B, C, D, E, F, G. And A, B, C, D, E, F, G will be preferred to A, B, C, D, E, G. So this path A, B, C, D, E, F, G will be preferred to A, B, C, D, E, G because both have the part A, B, C, D, E. After that, you could go E, F, G or you could go E, G. E, G was 8, E, F, G was 6 and E, F, G has been preferred. 38, 40 and there is another 40. So I would remove, mark G, work for G, A, B, C, D, E, F, G at the cost of 38. And now neighbors of G. There are no neighbors of G which are not marked. E and F both are marked. So now there are two more things to remove. D will be removed. Why? There was a star on mark also. So if you remove a guy which is already marked, you don't work for it and you do not do the next two steps for it. That is why mark had a star. So when I removed D was already marked, so you don't have to do anything. Now G got removed and G was also already marked, so nothing to do. Is the algorithm clear or not clear? Did you understand the Dijkstra algorithm or not? Should I do it again? Once more? I want to do it once more. Please give me a thumbs up so that I can discuss it once more, because I want to discuss it once more, because then I will be throwing you an example and then you will have to solve that example. I will do it quickly. Don't worry. So now you know the algorithm is remove, mark star, work, neighbor star, and you know there is vertex, there is path so far, distance so far. You guys know that. So this is your graph. A, B, C, D, E, F, G are the name of your cities. This is the distance of the roads. All right. With me so far? All right. So I would make the table somewhere here. I will make the table here. So initially I add A0 to the tree. Remove, mark, work, A0. Add the neighbors B and D. So B will be added, D will be added. For B, AB. 0 plus 10, 10. AD. 0 plus 40, 40. 0 plus 40, 40. So I will remove B. Remove, mark, work. Neighbors A and C. So I will only add C. C, A, B, C. This 10 plus this 10, 20. Remove, mark, work, add the neighbors B and D. So I will add, B is already done, I will add D. D, A, B, C, D and 30. Now is the moment to realize the beauty of the algorithm. So both the paths have been detected. AD, A, B, C, D have been detected. And because you remove the shorter one, so you will remove this one. D, A, B, C, D, 30. Remove, mark, work, neighbors. Neighbors are A, C and E, so I will add E. I'm not doing it any further, assuming that you have understood the algorithm. Have you guys understood the algorithm? Did you enjoy the Dijkstra algorithm? All right, all right. So now let me test your learnability. Learnability. Learnability tells me that you guys paid attention and could understand that. So I would throw you a graph now. Actually, this is the same graph. Same graph. I would not change the graph. The question can be changed by changing the starting point. F, G, 10, 10, 10, 40, 2, 3, 3, 8. So your output is that table. Output is that table. Starting point is C. Give me the table. Starting point is C. Oh, yes, D is also very nice point to have. Starting point is D. Solve for D. Solve for D. Because D is the corner point, no? So it's a good point to explore the Dijkstra algorithm. Starting point is D. So now the question is in your hands. You have to give me a table back. Give me the entire table back. Entire table back. Give me the entire table back. The table will have 7 entries. There are 7 vertices, no? So 7 entries. So over to you. Please do not post the answer in public. Post the answer in private. So you solve the question. I will have a drink of water. I think it will need you 3-4 minutes at least to solve the question. Let's see. This is 133. Let's discuss it at 138. Rohit, the next session is on 13th, no? There is no session on 9th. Don't worry. Let me see the questions for a while now. Priyanshu, I would address the question. Don't worry, don't worry. Okay, let's solve the question together now. Let's solve the question together now. All right, let's start. Please, please. Your answers are coming one piece at a time. So I cannot take a look at the entire table. If I cannot take a look at the entire table, then not fun. All right, let's do it together. D0 starting point. Remove, mark, work. D0 is the work. Neighbors A, C, and E. A, C, and E. AD, 0 plus 40. CD, sorry, not AD, DA. The path would be called DA. The path would be called DC. DC at 10. E would be reached via DE at 2. DE2. So I think which one would be removed now? After DD0, which one would be removed from these three? E. Remove, mark, work. E, DE2. Neighbors. Neighbors of E are D, F and G. So D is done, F and G would be added. F and G would be added. The path would be DEF and DEG. The cost would be 2, EF is 3, 5. The cost would be older 2 and EG is 8. EG is 8, so 2 plus 8, 10. So now which one do you think we would remove? Which one would be removed now? F would be removed. F, DEF at 5. Remove, mark. So remove, mark, work, neighbors. E and G are the neighbors, so E is added, I will have to add G. D, E, F, G. Old is 5, 5 plus 3 is 8. So now I think I can see a 8 here, 10 here, 10 here, 40 here. So 8 will be removed. Remove, mark, work. G, D, E, F, G, 8. Anubhav, I will check. G, D, E, F, G, 8. Neighbors. Neighbors are E and F. They are done. So nothing to be added for G now. Okay. What's the next one to be removed now? 40, 10, 10. So this 10 can be removed. Remove. If they are two equal, you can remove it, whatever. Remove. Because it is already marked, so nothing to do. It is marked, so nothing to do. Okay. Remove C. Mark, work. C, DC, DC, 10. Neighbors of C. D and B. D is done, so I'll add B. B, DC, B at the cost of 10 plus 10, 20. Remove, mark, work. So I'll write it here B, DC, B, 20. Neighbors of B are C and A. A can be added. A, DC, B, A at the cost of 20 old plus 10 now 30. Now 40 and 30. Remove, mark, work. A, DC, B, A, 30. And neighbors are B and D, both are done. Remove, it is already, remove, it is already marked, so nothing to do. So this is my table. Is your table same? A, DCB, A 30, correct. B, DCB 20, correct. D, D0, C, DC 10, E, DE 2, F, DEF 5, G, DEF, G8. Correct. So Bhavesh, Janish, Rishi checking for you. DD0, E, DE 2, F, DEF 5, G is correct, C is correct, B is correct, A is correct. Awesome. Did you guys see that it was smart enough to not take the DA path but DCBA path? Did you guys realize that? It did not take the DA path. It was smart enough to take DCBA path. DCBA path. Yes, Harsh, these questions can be asked in MCQ also. Don't worry. You can be taught an article and then you can be asked how much is the cost to A. And for that, you have to run the Excel algorithm to give the cost to A. So MCQ can still be. Yes, Anubhav, it is good for time complexity. It's the best algorithm for shortest time path. So single source, shortest time is the best algorithm for that. Yes, Janice, correct. It is similar to that only. All right. I hope you enjoyed this. So no more questions today. We did 4, but we also did at least 1 interesting question. The 3 were maths question. So a quick recap on what we did. So we did the Xtra. We did the bulbs problem, which was bulbs problem only in name, which was actually a number theory problem. We did that odd even problem, 1999 problem. There was a hidden thing there. The XY plus YZ problem. So this is the problems that we did today. We would do another 6 questions in the next class, which would majorly be DP and recursion. Okay. Rohit, yeah. So I'm sharing you the resources. Don't worry. So if you do not get an opportunity to attend the next session, so let me share where you can prepare from. All right. So I have taken these sessions previously also. So you can go to Scaler School of Technology. And you can go to this channel, and in the videos you can see the 4 videos, these 4, 1, 2, 3 and 4, 1, 2, 3, 4. These 4 videos are from my previous bootcamp, and I have discussed many resources from where you can prepare. So do watch these 4. This would point you to further resources to learn from. So this is one place to learn from. How is Arch browser? I don't have a Mac, so that is not a problem. No, Arch browser is good enough. Okay, all right. So there are a few queries here. So one of the queries was from Priyanshu. How are the placements of SST? As of registration is going on, should we consider SST? So let me answer that question. So why I would say this is one of the best colleges around. So I have a very clear opinion here. Of course, I am skills employee, so you can decide to take my opinion with a pinch of salt. But let me share you. SST is the most exciting engineering college right now. Why so? Why so? If you can see my screen, I will tell you. So I see it for 5 points. One, a usual engineering college, no, even when you are doing computer science degree, 50% of your curriculum is computer science and 50% is chemistry, maths, sometimes even physics. So a lot of other stuff, at least 50%. In SST, 100% of your curriculum is computer science. So for a lot of people, in many places, what is happening is they go to their college to have their degree, and then they have to go elsewhere to have extra knowledge, so that they could be relevant for companies, which is not true for SST. Okay, so 100% of your curriculum is CSE. Second thing, in most of the colleges, the instructors are fine people. They have their PhDs, they have done researches, which is great, but they need not necessarily be programmers which have worked in companies like Microsoft, Amazon, and Google. In SST, your trainers are people who have worked with such places. So your trainers are people who actually worked in the past in Google or Microsoft. So one of my students, Aman Rajput, so he worked with Microsoft and now he's a trainer in SST. So your trainers are programmers themselves. Third thing, this is in Bangalore and this is in the heart of the electronic city. So where there are so many companies around, you would get, so let's say you are hanging out for dinner and you would see a Microsoft engineer right there. You can just take guidance from him because of the location. And because of the location, the number of companies hiring also increase. All right. One more thing that is very critical is the network. The network. What do I mean by the network? So Scaler is funded by Sequoia. It was previously called Sequoia, now it is called Peak 15 and Tiger Global. India has 112 unicorns, 112 new companies which have crossed the valuation of 8,000 CR. Sequoia and Tiger Global have invested in 60 out of them, 60 of these 112 unicorns. So, and Sequoia and Tiger Global have also invested in Scaler. So, these companies belong to Sequoia and Tiger Global, and Scaler also belongs to Sequoia and Tiger Global. So they always have this network of 60 unicorns. And so what happens is they have those founder retreats. All the founders from all these companies get together and discuss problems. So all these 60 companies, they have a persistent recruitment problem. So we want talent which we can rely on. And one of the companies is solving this problem in the Sequoia portfolio itself. So this solves a lot of stuff. All right. Finally, I would say the culture, because of the 100% curriculum of computer science, the culture becomes the kind of culture where it is not celebrated whether you are good at dance or not, but it is celebrated that you are good at robotics. So that builds a culture in the college. And that happens when 100% focus is on one thing. The key thing about focus is when you focus on one thing, you do not focus on the rest of them. So yes, the bootcamp is, I think, good enough. So do watch those 4 videos. In those 4 videos, I have pointed out other resources also. Do go through all those resources, and I'm sure you would be. So the previous students who attended my bootcamp, they came back to say that they were helped in the bootcamp. The bootcamp helped them crack NSET. So I hope this would work for you also. Yes, Anubhav, do send me a LinkedIn request. I would contact you. No problem. All right. So it was lovely teaching you guys. I hope you also enjoyed the session, and would love to see you in SST someday. Okay. So I may be coming to teach there also around, I'm not sure, maybe around July. So I may be coming down to teach in Bangalore in SST. So would love to see you guys there. All right. Saksham, I have commerce with IP without maths, and I say I'm good at Python, but as maths is mandatory. What if I take the coaching of maths for a few months and then apply in December, Jan? Saksham, I say this is a fine approach. I would say keep on trying even without maths. Don't worry, and once you have taken some coaching on maths, then I'm sure these would not be difficult for you. It would not need too many months. So CAT preparation does not take too many months. So the CAT kind of maths is what is required here. All right. Rohit's question is answered. What will the student assist for in the interview? Yeah, Virat. So why do we take an interview here? Is because we want to see what was the reasoning behind your answers. For example, the questions that I asked today. So some people would think this is an MCQ. Why do I need to give the reasoning? Because after the NSET, there is going to be an interview, and in an interview, what we do is we pick up the MCQs that you have given answer for, and we ask you the reasoning for that. So reasoning in interviews, you are assessed for the reasoning of why you answered whatever you answered. Kshitish, the number of questions are 180, I think. Sadik, I am sorry, I cannot answer this question. I am not sure. Fadil, I don't think Fadil, NIOS is not a problem. So that is accepted everywhere. Priyanshu, your question is answered. Jenish, time complexity is not asked. Don't worry. Okay, Rohit, I do not know the answer of this. I do not know the answer whether Scaler provide laptops or not. What will be the marks required in NCT exam to get admission in SST? I think anywhere around 50% should be enough. All right. All right. I hope you enjoyed the session. I enjoyed talking to you guys a lot. So would love to see you again on 13th. That is next Thursday, I guess. So love to see you then. And I would teach you some recursion and some DP. Some recursion, some DP. So that is going to be a very interesting class. And there is a very interesting puzzle that I do, rats and poison. That is a very interesting optimization class. Yes, Anubhav, I am the one who lifts. Yes. I am the one who lifts weights. Yeah. I've been doing some powerlifting for some time. All right, guys. See you. Bye. Lovely talking. Bye. Aman, yes, I think this class will also go on YouTube. That is not a problem. Bye.